Welcome to Introductory Chemistry. In this chapter, we'll be talking about atoms and elements. And the key concepts are atoms, atomic particles, subatomic particles, and such as mass, proton, neutrons, and later we'll get into electron configuration as well. Okay, those are the key concepts. The back in the old day, around 400 BC, scientists already discover indivisible particle called atoms, and actually in the old day they call atoms. And then around 2200 years later, John Dalton's formalized the atomic theory, define hydrogen is the smallest particle of matters, which is known as atoms. Okay, and then later we have a few famous experiments. One of them is the cathode ray tube experiments, in which Thomson discovered a beam of particle and known as electrons. Okay, now he also proposed the plum pudding model of the atoms, and asked his student Rutherford to prove that. And basically, the plum pudding model said that electrons are negatively charged and protons are mixed in an atom evenly. Okay, it turns out that's not the case. When Rutherford used a piece of thin gold and sent in the alpha particle, it turns out all like 99% of alpha particle went right through the piece of gold. So Rutherford figured there must be a gap, between those in that piece of gold, and then that's how he discovered the structure of an atom, which consists of a solid nucleus and electron cloud moving outside. So you can see here each sphere is an atom with a red dot in the center. That's the nucleus, and the electron cloud. So electron cloud is basically empty space, and the beam, that's why the alpha ray can go right through. Only the one that hit right in the center, which is the nucleus, get reflected, or hit on the side get deflected. Now we got a modern theory. Any periodic table you look at, like for example this one, you look at a periodic table, for example, Mercury is right here. You see two important numbers. One is to call the atomic numbers, the smaller numbers. One is the larger number, it's about 200. That's the atomic mass. And the old-fashioned way, we put the large number on top, and the atomic number is the smaller one on the bottom. But the new way nowadays, they are all over the place. Okay. Notice that the atomic number is the number of proton, and the number of proton also equal to the number of electron if the atom stay original condition, which is neutral. Okay, atomic mass is the number of proton plus the number of neutrons, and like I mentioned right here, if the atom is neutral, the number of proton equal to the number of electrons. Okay, we can, in terms of mass, the actual mass of a proton or a neutron is really small, and but so to make it easy, we call that a proton is 1 AMU, and the same for a neutron. Okay, very close in mass. However, the electron is so small, it's 1800 times smaller than a proton or a neutron, so we just call that a zero. Okay, so for us, an electron is almost has no mass. Now back to the periodic table, you can see over 100 different kinds, and those are elements. Each element is a fundamental substance that cannot be broken down into simpler substances, and the smallest particle of each element is called an atom. Okay, so you got a periodic table of all these elements arranged in columns. We call them group, and also arranged in row, we call them periods. So you got period 1, you got period 2, so on and so forth. Column, you got the group 1, group 2, all the way to group 18. And this is a good table because it also has the original naming system, which is group 1A, 2A, and then all the B's are here. And then you see 3A, 4A, all the way to 8A. Okay. Now going back to this, an element, if you notice that on the table is abbreviated by 1 or 2 letter symbol, and the name come from based on the property, the founder who discovered them, or places where they are discovered. Okay. For example, sodium is Na. The original name is actually natrium. Nitrogen is N. Instead of 2 letter, it's just 1. Because if you write Ni, that's another element. That's nickel. Californium, this is really cool one because CF is Californium. It was discovered in California. It's named after California. Okay, so if we're in California, we got an element named after our state, which is really awesome. Mercury, you know, Mercury is named after the planet Mercury, and so on and so forth. Okay, there's also one that's named after Einstein. It's Einsteinium. The and it's right here. Einsteinium is number 99, right next to Californium. Okay, Californium is 98. Einsteinium is 99. Okay, be able to name the group. Okay, remember the group was columns, and there's special name for some of them, like alkali metals is group 1. I specify right there, and I give you a few examples. The whole thing in that group: lithium, potassium, sodium, rubidium, so francium, so on and so forth. Alkaline earth metals are the one on group number 2, starting with beryllium, then magnesium, and then calcium, so on and so forth. Transition metal, you got the whole block going from group 3 to group 12, all the B groups. Okay, those are the few examples. And then you got halogens, group 17. You got noble gases, group 18, which is the last one on the right. Okay, you also have need to be able to identify metals, non-metal, and metalloids. The on the left side of the staircase, okay, and I label the staircase. These are the elements in the staircase. They are non-metal, they are metalloids, sorry, okay, and they're right here, okay, in this range right here. Those are the metalloids. They separate the metals, which is on the left side, metal, remember, on the right side, non-metals, okay. On the borderline, those are metalloids, okay. Let's go back to this, and a little bit of physical and chemical property of these metal, non-metal, and metalloids. Metalloids have both metallic and non-metallic properties. Metals are good conducting heat, and electricity, while non-metals are not. In terms of chemical property, metals tend to lose electrons when combined with non-metal, and obviously non-metal accept electrons. And if you need more information, there's more information in the textbook. Okay, notice that there's 7 elements, and if you want to work with them, okay, they only exist in diatomic form or in pairs, and that's iodine, hydrogens, nitrogen, fluorine, oxygens, chlorine, and bromines. Only diatomic form. These are the gases. Except iodine is a solid at room temperature, but if you warm up a little bit, it becomes a nice purple gas. Now ions, when notice that the in the center you have the nucleus. A nucleus consists of proton and neutron in the center of an atom. Outside the nucleus, you have electron, and they can be lost, or you can have incoming electron to join. Okay, so when an atom loses electron, it forms cation, which is positive ion. And here's a few examples. You have sodium plus, you have calcium 2 plus, you have aluminum 3 plus, and they are formed by losing 1 to 2 to 3 electrons. Okay, 4 electron is not very popular. All right. On the other hand, if you have an atom that gain electron, it becomes a negative ion, which is known as anions. In this case, I also give you 3 examples. For chlorine, gain 1 electron, become chlorine minus 1. Sulfur gain 2 electron, become minus 2. And similarly, nitrogen gain 3 electron, become minus 3. Now, and then if you just look at the group, how would you know which one? Which one is the charge of which ions, right? And here's the patterns. Group 1 or group 1A is, if they form ion, it's always going to be plus 1 or 1 plus. Group 2 always going to be 2 plus, and group 13 or 3A is going to be 3 plus. On the negative side, you got a group 15, 3 minus, group 16, 2 minus, group 17, 1 minus. Okay, and you also have some in the transition metal block, group number 3 to group number 12. Most of them can form more than 1 ion. For example, copper can form either plus 1 by losing 1 electron. Remember, losing electron become positive. Copper can form plus 2 or 2 plus by losing 2 electron. Similarly, you have Fe can do that, and lead. Okay, oxygens mainly form the 2 minus by gaining 2 electrons. However, you also have peroxide, which you have 2 oxygen gaining 2 electrons, and that means 1 electron each become peroxide, which is the 2 minus for a pair of oxygens. Okay, here in the here let's go back to this. Okay, so so that's ions. Okay, now in terms of isotopes, it's possible that 2 different atoms from the same elements having different number of neutrons. That's possible, or even 3 or 4, and those are called isotopes. They have, for example, this copper 63 and copper 65, they both copper, so they have the same number of protons. Remember, protons are really important. That's identifying the elements. But these 2 are isomers. The isotopes. They have different number of neutrons. And remember, neutrons are neutral, so it's okay to have more or fewer. Okay. These copper 63 has 34 neutrons. If you take 63, you minus 29, you get 34. While the 65 copper has 36 neutrons, because you take 65, you minus 29, you get 36. Okay, so remember, you take the mass, you minus the number of protons, you get the number of neutrons. Okay, and finally we have electron configuration. So we got the proton and the neutron inside the nucleus. That's taken care of. So now, how about outside the nucleus? You have flying electron, right? And these are the order of the orbital of electron. The letter indicate the type of orbitals. Okay, so here I give you a few simple ones from lithium to carbon. Lithium has 3 electrons total, beryllium 4, boron 5, and carbon 6. And now, how that means these are number of electrons. Okay. And how do we organize them, right, in orbitals? And we create these boxes. Each box is an orbital, and you can see level 1, which is we call 1s, and then you go to level 2. And they all start out with level 1. So you see each arrow is an electron. Okay, so 3 electrons, you fill up the box. Maximum 2 in a box in an orbital, and that's 3. And then you have 4, 5, and 6. Okay, notice that valence electrons are electrons in the highest energy level. So we don't count the first level. unless there's nothing in the second level. If you have something in the second level, you only count the second level, and that's known as valence electron. So if you look at lithium, that's one valence electron. You look at beryllium, that's two valence electron. Remember, you don't count the first level. You look at boron, you have two here, but you have one here as well. So that's three valence electron for boron. And finally, carbon here has two here plus two, that's four valence electron. And so on and so forth. So if you have more, then we can keep going and keep going. All right. All right. Thank you, guys. That's it for atoms and elements. That's chapter 2. Okay. And hope to see you in the next one, chapter 3. Thank you. Bye-bye.